Hello everyone. So today I will be explaining the implementation of hidden Markov model using an experiment. So the objective of this experiment is to implement hidden Markov model using NumPy and Python. And our main goal is to compute the probability of the observed sequence using the forward algorithm and to understand how the hidden states influence the observable outcomes. And using that, we are predicting the most likely sequence of hidden states with the help of the given observations. So in this problem, we are trying to estimate the weather condition, that is whether it is sunny or rainy based on the given data. So first, let's see what is a hidden Markov model. So a hidden Markov model is a statistical model where the system is assumed to be a Markov process with hidden states. So we cannot directly observe the states, but we can only observe the outputs which are influenced by those states. So what is a hidden state? A hidden state in this case is, for example, like sunny or rainy, and the observation is, for example, whether there is an umbrella seen or there is no umbrella seen. And the transition probability is the probability of moving from one state to another, and the initial probability is the starting probability that is given to each state, and the emission probability is the probability of observing an output given a state. So now let's understand the code. So first we are implementing or importing all the necessary packages. So we are importing the NumPy package, which is used for performing the matrix operations. And next we are defining the hidden Markov model parameters. That is, first we are initializing the transition matrix. So the transition matrix gives us the probability whether it will stay in the same state or switch to different states. For example, if today sunny is 70%, then there will be a chance that tomorrow will also be 70% sunny. Next we have initial probability. So initial probability gives us the initial value given to each state. So we assume that there is an equal probability of sunny or rainy in our case. And then we have observed sequence. So the observed sequence is probability of an event occurring. That is, 1 means say an umbrella is seen and 0 means no umbrella is seen. And next we have the emission matrix. So this gives us the probability of observing data given hidden states. For example, if sunny means there is a low chance of umbrella, and if it is rainy, then there is a high chance of umbrella, like 0.8%. And next we are computing the forward algorithm, and we are storing the value in the alpha variable. So we create a matrix which will help us store the forward probabilities. So here we are multiplying the initial probabilities with the emission matrix, and this line will calculate the probability of the starting state with respect to the first observation. And next we are computing the recursion step, that is the for loop. So here what we are doing is we are computing the probability of each of the observed sequence by going within the loop for the observed sequence, and for each observed sequence we are also calculating the initial probabilities, and we are multiplying the previous probability with the transition matrix and the emission probability, and all these values are stored in the variable probability for each of the given observation. And next we are calculating the final probability and storing it here, as I've said before. And next we have the most likely sequence. So we are computing the most likely sequence based on the probability that we have calculated here above. So if for each of the observed sequence, we will see if the probability for, say, sunny is greater than rainy, then the most likely sequence will be sunny. And if the value of observation for sunny is for rainy is greater than sunny, then we will say the most likely sequence is rainy. And while we run the program based on the given observations and the inputs that we have given, we are getting the probability for observed sequences, this value 0.089, and the sequence as given here. So what are the applications of hidden Markov models is, it is used in various applications, like we are using it in speech recognitions like the Alexa, Siri and Google Assistants, and then we are also using it in natural language processing, and also for mainly for weather forecasting purposes like we have seen here, and we are using it for say finance like stock predictions, and also in bioinformatics for gene prediction problems. So with this I conclude my explanation. Thank you.